So in this video, I'm going to explain uh, problem 6, which is skipgram with negative sampling. So skipgram is a popular word to vector technique used to learn word embeddings. The main idea is simple. Given a centaur word, the model tries to predict the words that appear around it. To make training faster, this implementation uses negative sampling instead of considering the entire vocabulary for every training example. At first, initially, the program starts by importing the libraries, and thereafter, the main class is called skipgram negative sampling. So it takes two parameters, that is vocabulary size, which is the number of words in our vocabulary, and embedded dimension, which is the size of each word vector. Inside the constructor, we create two matrices, that is W word and W context, and both are initialized with random values. The word matrix represents the center word embeddings, while the context matrix represents the context word embeddings. And next we have the build sampling table. The negative sampling requires us to select words that are treated as incorrect or negative example. So instead of sampling words according to the raw frequency, this implementation raises their frequency to the 0.75 power. The adjusting probabilities are then normalized and converted into a cumulative probability table. So this is useful because very frequent words should be sampled less aggressively than their raw frequency would suggest. A simple negative function generates random values and uses the sampling table to select negative word indices. The next is the most important function, which is the train step. So first, so in this train step, it calculates the dot products for the positive pair. A high dot product means the model behaves the two words are related, and for a negative pair, we want the dot product to be low. So the program uses the sigmoid function to convert these scores into probabilities. The loss function encourages the model to assign a high probability to the real context word and a low probability to the negative sample. So after calculation the losses, the program calculates the gradients of the center word vector and positive context words and the negative context words. These gradients tells us how each embedding should change to reduce the error. The vectors are then updated using gradient descent, and the default learning rate is 0.025. The process is repeated for every center context training pair over many update words that occur in similar contexts gradually develop similar vector representation. Now let's see the output. So it initially loads up 10,000 tokens, and the vocabulary size here is 5,000, and these are the training samples. We have done three efforts, where in three efforts the loss is minimal, and thereafter the similarities. In similarities, man and woman has 0.8223, and this is the complete implementation. Thank you.